Hello everybody and welcome to a new video for topic 5. We're going to be jumping into rational exponents and radical functions. So here we're going to see how the radicals are related to rational exponents, what are the relationships between a relation and its inverse, and things like that. All right, so we're going to start with lesson 5-1 topic 5 lesson 1, and we're going to look at nth roots, radicals, and rational exponents in this one. All right, some things that you should get out of this is how are exponents and radicals used to represent roots of real numbers. Some important vocabulary here because you're used to seeing this as a square root, but we don't call this a square root. We call it a radical. So we're going to be updating your vocabulary when we're looking at radicals. So know that they have parts to them. They have an index. The index talks about the root, so your nth root. The radical symbol, which is that like check mark symbol with a long tail, and a radicand, which is a number found inside. All right. We'll jump straight into example 1, finding the nth roots of this problem. All right, so what are the real cube roots of 125? I have it nicely over here. All right, the book does this in an odd, strange way. I'm going to do it in the book's way, and then I'm going to do it just kind of the way I would do it. But what they want us to do is we need to first define what things are. So the nth root of a number c is x, such that x to the n equals c. An nth root can be denoted by a radical symbol, the radical symbol again being this kind of long check mark, with the index of n. So the little index goes here. Now, you would notice when we talk about square roots, we don't put an index here. It's implied with a square root that you don't need an index, that's automatically 2. It's like if I had the power of x to the first power, we're not going to write x to the first power because, again, that variable x is seen over and over again. So we still do have an index when we talk about square root. It's just hidden. It's just left out. So denoted by the radical symbol with an index n is called the radicand. So this guy right here is a radicand, radicand. This value right here is the index. And this right here is the radical symbol. To represent the real cubed root of 125, we write that x is equal to the cubed root of 125. So the next thing I'm going to do is I'm going to solve for x. I'm going to cube both sides. All right, and you might be thinking, well, Miss Ebony, we could just throw this in a calculator. Again, we're going to go through the steps to see how to find it, so you have that baseline, that underlining viewpoint of how to solve this. So now I have x cubed equals 125. To solve this, I'm going to move this guy over here. And I'm going to be left with x cubed minus 125 is equal to 0. So now we're going to look at the difference of cubes. Because again here, I have a perfect cube here and a perfect cube here. So this is x minus 5, x squared plus 25. No, it's 10x. It's 5 plus 5. 5x plus 25. That's where the 25 goes. So just a reminder, because obviously we need these reminders. A squared will equal x minus a, x squared minus plus ax plus a squared. And there you go. There's your identity. All right. So looking at this, we know that this is going to be x equals 5. But if we look at the discriminant here, remember the discriminant is going to be that b squared minus 4ac from the quadratic formula. If we look at the discriminant here, we have 25 minus 4 times 25, which is going to be negative 75. So this would give us an imaginary or a complex number. So therefore, we only have one real solution, and there is only one real cube root of 125, which is 5. Again, do we have to go through all that? Probably not. Again, the book is showing you why there's only one real root. If I have the cube root of 125, I know that anything cubed, if I have a negative 5, then that would give me a negative inside this cubed root, because negative 5 cubed would be a negative times a negative times a negative. So the only one is 5 here. So in other words, I would do it like this, and we'd get 5. Right, so let's go back here. There's a part 2. What are the real fourth roots of 16? Again, I'm going to do the book method here. Get rid of that. So they want us to do the fourth root of 16. That's going to be equal to x. Then I have x to the fourth equals 16, because I'm going to fourth exponent both sides. That's not a b, that's a 16. Subtract 16 from each side. Do I have to go through all these steps? If I know that a value to the fourth will give me positive or negative value to the fourth would give me that 16. No, I wouldn't. Again, we're looking at identity here. We're looking at the difference of squares, which gives us x minus a, x plus b equals x. I like how I say x and I write an a. Where would it be here? Instead of an a, x squared minus a squared. So that's all I did here. I noticed that these are two different squares. This one is going to give me a complex value. If you remember, the sum of squares is going to be x squared minus 4i, x squared plus 4i, or not squared, just x, Monday mornings. But this is a difference of squares, x minus 2. And I found a mistake here. I put 16 instead of 4. I'm going to chalk it up to a Monday morning. X plus 2. Okay, if I set these each equal to 0, I get x equals plus or minus 2. This is my only solution because this is a complex solution. Or, and you can tell that I've never really done my solutions in the way that they're doing it. I just know And this is just from experience or practicing, or just even thinking about it. 2 times 2 equals 4, times 2 equals 8, times 2 gives me the 16. So I have the 1, 2, 3, 4. So this is 2. You could also do a factor tree. 16. You could have 4 and 4, which is 2, 2, 2, 2. Okay, I have 4 of these. 1, 2, 3, 4. That is my goal. So that's 2 to the 4th. And remember, this could be both plus or minus, because anything raised to an even power will give you a positive value. So again, you could do it that way. All right, so your try it, find the real fourth root of 81 and find the cubed root of 64. Again, I would just, if you have access to your calculator, you can use that. If not, you can just do factor tree, because remembering all those identities to solve all this can be kind of a little much. All right, guys, so I hope you have a great day. Sorry for this choppy video. It is a Monday morning. I hope you don't have to erase too much, and I will catch you in the next video.